Yes, class. So see, we were doing the revision of motion in a straight line. So let's continue with that only. Motion in a straight line we had started. Some of the questions we did, some of the questions were left to be discussed from the first lesson only. So let me just share the question with you, then you can start. What all things we discussed? Let us just have a look. So till motion uniformly accelerated motion equations, that also we started. That yes, Khadija, how's your preparation going? Just update me in the chat column once, Khadija. Okay, Khadija. So any particular doubt which you are having? If any doubt you are having, that also you can share. The way you were sharing, that also can be discussed today, if any specific. Otherwise, questions I am going to practice with you. Okay, no, not right now. All right. And Siddhika, what about you? How's your preparation going on? Okay, gravitation you need to practice. All right, Siddhika, if any particular doubt you have, that also you can share. All right, so see this, a motor car starts from rest and accelerates uniformly for 10 seconds to a velocity of 20 meter per second, right? It then runs at a constant speed and is finally brought to rest in 40 meters with a constant acceleration. So what all things we have? It is starting from rest, accelerates uniformly for 10 seconds, velocity 20 meter per second. It then runs at a constant speed and is finally brought to rest in 40 meters with a constant acceleration. So here you have to notice that the speed was constant. If speed remains constant, acceleration automatically becomes zero with a constant acceleration. Here you can apply the uniformly accelerated motion equation, because in this case now acceleration is constant. Total entire distance which is covered is 640 meters. You have to tell the value of acceleration, retardation, total time taken. 1 minute I'm giving, read the question, try it yourself, at least frame the basic, and if you get the answer, quickly respond me in the chat column, then I'll discuss it. I have told you velocity is constant here, acceleration is zero, but here acceleration itself is constant. And the total distance of the entire journey is 640 meters. After 40 meters, what happens? And everything is given. Just try, make at least a rough sketch of it. See, a motor car starts from rest. So let's say initially this is starting from rest, u is equal to 0. It accelerates uniformly for 10 seconds to a velocity of 20 meter per second. Then it runs at a constant speed. Here this is 20 meter per second because speed is constant. So if here it was 20 meter per second, here also it will be 20 meter per second, right? And it is brought to rest, then rest means this final velocity will be 0. So V1, V2 and V3. This is brought to 0. In 40 meters, this is 40 meters with a constant acceleration. This total distance which is covered, this is 640 meters. This. Find the value of acceleration, retardation, and total time taken that we have to calculate. Firstly, if we talk about the first part of the motion, initial velocity, final velocity, and time is there. Can we at least find out the acceleration? So for the first part, u is equal to 0, v is equal to 20 meter per second, time is equal to 10 seconds. V is equal to u plus 80, 20 is equal to acceleration into 10, 0, 0 cancels, acceleration is equal to 2 meter per second square. At least you now have the acceleration for this part of equation. This acceleration 1 comes out to be 2 meter per second square. Now, but we need the distance. We need every quantity. Then only we'll be able to calculate. So what will be the distance? Distance will be S is equal to UT plus half AT square. So when you substitute this, U is 0, it is initially at rest. So 0 plus half acceleration is 2. Time is given as 10 seconds. So this is 200 by 2, which is 100 meters. So this first distance is 100 meters. So it means this is T1, S1, this much part, this is 100 meters. This is 40. So how much will be this? 500 meters. So you have the second distance also. So what will be the acceleration? Because velocity is constant. So for the second part, look for the second part. Velocity is 20 meter per second. Distance is 100 meters. Distance is given as 100 meters. And what all things are there? Time at least we can find out. So time will be equal to distance. See, distance is equal to speed by time. Time will be equal to speed by distance. That is, what is the speed given? 20. This is, I have written this opposite. This will be 100 by 20. So yes, speed is equal to distance by time. From here, time will be equal to distance by speed. Distance is 100, speed is 20, cancels 5 seconds. So T2, second time that is coming, T2 is equal to 5 seconds. So what all things are missing here? Acceleration. How will you calculate acceleration? Acceleration will be 0 in the second case. Reason? Because velocity is constant. So acceleration will automatically 0 whenever you have such case. Second part also done. Time, distance, acceleration, everything we have. All the information for the second part is calculated. This is the acceleration is simply 0. This is 500. Time is 5 seconds. Every detail has been calculated. Come to the last part. Last part. Distance is 40, 20 meter per second, 0. This is the final velocity. Come to the third part. Third part will be v is equal to u plus at. Final velocity is 0. Initial velocity is 20. Plus acceleration we do not know. What do we know? We know the distance. Okay. Let us use the other equation. V square minus u square. Because distance is also missing, time is also missing. So v square minus u square is equal to 2as. V square is 0 square, u square 20 square is equal to 2 into a into 40. So this is minus 400 is equal to 40 into 2 into acceleration. Acceleration is minus 400 divided by 40 into 2. This cancel. This is 10. Acceleration 3. This is minus 5 meter per second square. Now, the question that arises is, why is this acceleration's value coming so negative? Why is there a negative? So basically, this negative sign tells you the fact that this is negative acceleration, tells the fact that this is negative acceleration, which is called as the retardation. And why does it occur in the system? Because velocity of the body decreases. This is the reason. So mark this as important question. Practice it yourself as well. Write it down. See, this is the next question. All those who have written it, attempt with this. A body covers 12 meters in second. Now, the class, pay attention when you are attempting this question, because this is not 2 seconds. There's a difference between when we say t is equal to 2 seconds and when we say second. There's a difference between them. So pay attention to it. Covers 12 meters in seconds and 20 meters in fourth second. This is fourth second. Again, likewise, there's a difference between t is equal to 4 seconds and t is equal to fourth second. There's a difference between these two. Attempt it, try it, then I'll discuss. The main difference that you have to focus here is that this is not the just the simple time duration given class. It's not the simple time duration that we study, that this is t is equal to 4 seconds given or t is equal to 2 seconds given. This is different because here this is saying the time is fourth second. Here it is saying the time is second. That is, you have to use the equation for nth time, distance, nth time, distance equation. Clear? So see, for nth second, we have the formula as u plus a by 2 2n minus 1. This is the formula. So when we are talking about second, this becomes u by a by 2, 2 into 2 minus 1. This is equal to u plus a by 2. 4 minus 1 is 3. So this S2 is equal to u plus 3a by 2, right? When we're talking about the fourth second, S4 is equal to u plus a by 2, 2 into 4 minus 1. That is u plus a by 2, 2 into 4 is 8, 8 minus 1 is 7. So S4 will become u plus 7a by 2. So this is the first equation that you have in your system. And this is the second equation that is there in your system. If you subtract these equations, if you subtract both the equations, or you have to both these equations, one thing that we can do, we can multiply this 2 throughout. We know what is S2, we know what is S1, right? S1 and S2 we know. So when you subtract, you get 2a is equal to 8. Acceleration becomes 4 meter per second square. So u plus 3 by 2 into 4 gives 12 meters, and u is equal will be 12 minus 6, 6 meter per second. And when you want to find out distance covered in 4 seconds after 5 seconds, same thing you can apply. One more method is there. What you can do, you can subtract S9 minus S5 so that you get S4. So once you put 6 into 9 plus half, 4 into 9 square minus 6 into 5 plus half into 4 into 5 square. This becomes 216 minus 80 is equal to 136 meters. Just you have to remember something in this question is this equation. This is the equation for nth time. Noted down everything? See, two buses A and B are at positions 50 meter and 100 meter from the origin at time t is equal to 0. They start moving in the same direction simultaneously with uniform velocity 10 meters and 5 meters. All right, determine the time and the position. Both of these things have to be derived. But first, if you write this in Cartesian form. See, coming to the derivation. Coming to the solution to this question. Here, directly equated. X is equal to x1 into 0 plus v1 into t. This is equal to how much? This will be 50t. If you put in the value, this will be 50 plus 10t. That is x1. Similarly, when you put the value of x2, x2 will be 100 plus 5t. Take their net solution, you get 5t is equal to 50, t is equal to 10 seconds. So x1 is equal to x2 is equal to 150 meters. Note it down. Note down the solution quickly.